this last example for a rational function that I'm going to go through is just really a special case, however should also be very familiar. So if you notice up here is the equation for just a special case of a rational function, and I like to call it the HK model. So of course I'm sure you note that there's an H and there's a K in there. So what you're going to do is you're going to start by noting that H is always going to be your vertical asymptote, and that's noted right here. So if you have x minus h, so for example x minus 3, x equals 3 will be a vertical asymptote. Y equals k is going to be your horizontal asymptote. So you'll have just one vertical, one horizontal, and then you'll just plot points from left to the left and to the right of the vertical asymptote, and then draw in the branches. So it's going to be very familiar to the last example that you watched, and also quite simple. So I'm just going to walk through one example of the HK rational function. Okay, so here we go. So you see that it's negative 6 divided by x plus 3 and then plus 2. So first you have to be able to look at this and say, oh, I recognize that this is an HK situation, because it's really the only time you're going to see the plus or minus something at the end of the rational expression. So I know that from the previous slide that x equals negative 3, and be careful with the tricky h, so you switch the sign. So x equals negative 3 is going to be a vertical asymptote, and y equals 2 is going to be a horizontal or end behavior asymptote. I'm just going to put VA for vertical asymptote. So I would then come over to my graph. I'm going to blow this up a little bit here. So x equals negative 3 is a vertical asymptote, and y equals 2 is my end behavior, which happens to be horizontal asymptote. So I would put those in for sure. And then I know that I'm either going to have branches going like this and this, or branches going in kind of second quadrant, fourth quadrant. So I need to test some points to the right of the vertical asymptote and to the left of the vertical asymptote, and enough to know where my branches are going to fall. So easy points to test would be definitely 0, maybe 2, and negative 2. And then, maybe negative 5, but I think I'll get an idea of what's going on here. So the points that I'm going to test, for sure, 0. So I'll just start there, and I'm going to talk through this because I think you can handle it. So if I put 0 in for x, that's going to be 3. Negative 6 divided by 3 is negative 2. Negative 2 plus 2 is 0. Okay, then I'll test, well, I'll plot that point first. So 0, 0, I know it's going to be a point. Actually, I will plot those later. I'm going to test positive 2 while I'm at it. So 2, if I put 2 in up here, 2 plus 3 is 5. Negative 6/5 plus 2 is 0.8. That's not bad. I can handle that. So 4/5 or 0.8. If I test negative 2 also on top of that, so negative 2 plus 3 is 1. Negative 6 divided by 1 is negative 6, plus 2 is negative 4. I'm going to stop there and make my graph a little bit bigger here and plot those points. So the origin is a point, 2, and then 0.8. So I'm just going to kind of squeeze that in there, approximate it. Negative 2 and negative 4, 1, 2, 3, 4. So that point is there. And I'm going to kind of bring this back down. It's pretty obvious that this branch is going here, which means the other branch, because I only have one vertical asymptote, is going to be up there. So really, if I just test maybe negative 5, that's probably going to give me a good enough idea. So if I put negative 5 in here, negative 5 plus 3 is negative 2. Negative 6 divided by negative 2 is 3. 3 plus 2 is 5. So negative 5, 5. Negative 5, 5 is going to be a point, and then I know my branches are here and here. So again, the key really, the testing of points is tedious, but the key for this problem really is just catching the fact that it's an HK model, because other than that, it really should be quite easy.